Hi, my name is John.
And my name is Alice, and this is Math Videos for Parents. We help you so you can help your kids. Today we're going to be talking about polynomial multiplication. So the way I learned it was distributing. So let's go over that to start. What I do is I'm going to take this x and I'm going to be multiplying it by every term in this second polynomial. The way I like to think of it, we have Thanksgiving coming up soon. I think of the X as like the appetizer, and it needs to be dished out to every person at the table, right? So the second polynomial is our table full of guests. So I'm just going to go through and do that multiplication. X times 2x squared gives me 2x to the third. X times 4x gives me 4x squared. X times negative 7 gives me negative 7x. So we've distributed the appetizer. Now it's time for some turkey.
I'm getting hungry.
So now I'm going to multiply the 3 to our table full of guests. So 3 times 2x squared is going to give me 6x squared. 3 times 4x is going to give me 12x. And 3 times negative 7 gives me negative 21. So now we're in good shape. We just need to gather our like terms. So what I'm going to do is look along this row. I see 2x to the third, and I scan down, and I don't see any other terms with x to the third in it. So that means my final answer is going to contain 2x to the third. Now I'm looking at this 4x squared. I scan to look for any other x squared terms, and there's one. So 4x squared plus 6x squared is going to give me 10x squared. And now the next one is going to be the 7x, negative 7x. I'll do a slightly different symbol there. I'm looking for any other x terms, and I've got one right there, 12x. So negative 7x plus 12x is going to give me 5x. And then I'm left with negative 21. And that is my answer. So, John, tell us about the box table method.
Sure. So one of the methods used in a lot of secondary schools is the box method, and it follows from the partial product method that we've discussed in some of our earlier videos, where younger students take double-digit numbers and break them down into smaller numbers so as to find smaller products to add together to get the final answer. With the box or table method for multiplying polynomials, what we do is the same exact thing, but for variable terms instead. So we take the x plus 3 and we break that up into x and 3, hence x plus 3. And for the other polynomial, 2x squared plus 4x minus 7, we can break that up into 3 separate terms, 2x squared plus 4x and minus 7. The idea, similar to that of the partial product method, is to compute individual products and then add them all together. But this method provides a sorting mechanism and some visualization for students if they prefer that kind of thing. So for the first product, if I want to find the area of this square, I would multiply length by width, or 2x squared by x, giving me 2x to the third. For the next entry, I will multiply 4x by x to find the area of this square, and 4x times x is 4x squared. I'm also going to find the area of the bottom left square, which I'll talk to you more about in a moment. This like rectangle square, whatever you want to call it, I guess we shouldn't assume that they're the same length and width, so maybe we'll use the phrase rectangle instead. We have 2x squared by 3, and that is 6x squared for this rectangle right here. All right, so now I'm going to go back up to the top. Let's find the area of the top right rectangle. So I have negative 7 by x. That product is negative 7x. And if I do this rectangle over here, the one that is like just diagonally to the left, 3 times 4x is 12x. And last but not least, the bottom right, I have 3 by negative 7. Those are two constant terms, and that is negative 21. The reason why I did such a weird order was when you do the box or table method, the entries that are diagonal from each other are like terms. 6x squared and 4x squared add up to 10x squared. So my green terms can be added together. 12x minus 7x, those are also like terms. They could be added together to make 5x. 2x to the third was the only cubic term, so I will leave that alone as 2x to the third. And negative 21 was the only constant term, so I will leave that alone as minus 21. This offers a visual way for students to find the product of two polynomials. And also, if students were exposed to the word FOIL, which is one of the most dangerous words you could use in secondary math, this undoes that habit. Students sometimes think that they have to do a first, outer, inner, last, regardless of how many terms are in the polynomial. So the box or table method offers a nice visual alternative that reinforces the need to give every person some stuffing or give every person some turkey. Every single term has to get distributed to every other term, whether we look at it through an area approach or a distributing approach.
And I really like this approach for the reasons you mentioned, and also just having the boxes or the table, if you will, it just provides nice scaffolding to make sure you aren't making a mistake. You know, the way I was doing it with distributing, I had to make sure I was hitting every term. And if I missed one, I didn't have a clue that I had missed it. But here I would have an empty square.
That's
that
a good point.
indicator.
Yeah. That's a really good point.
Excellent. I look forward to trying one.
All right. Go.
Okay, so now I'm going to use this method for this polynomial multiplication problem. So what I'm going to do is set it up just the way John showed us. I'm going to write 4x squared. And I'm going to set my table, so to speak. This is going to be x and 9. And these boxes are nice because I'm going to know for sure that I did all the multiplication that I needed to do. So I'm just going to go straight across the top row. X times 4x squared is 4x to the third. X times negative 2x is negative 2x squared. X times negative 3 is negative 3x. Now I'm going to go straight across the bottom. 9 times 4x squared is 36x squared. 9 times negative 2x is negative 18x. And 9 times negative 3 is negative 27. Now this is going to nicely just let me combine like terms right away. So I know that this is going to be by itself. It's the only x to the third. So that's 4x to the third. And now I'm just going to go on diagonals because these are like terms and these are like terms. So first I'm going to do negative 2x squared plus 36x squared. And that's going to give me 34x squared. And then I'm going to do negative 3x plus negative 18x, which gives me negative 21x. And then the final box is also going to be by itself because it's the only term without an x. So it's just going to be negative 27. And that is our answer. John, I really like that approach. It really sets it up nicely. It makes it easy to gather like terms. And I'm a fan. I'm hooked.
Everybody got stuffing. Everybody got turkey.
Exactly. All the plates are nice and organized.
All right. This was great. Thank you so much, Alice.
Thank you, John. And if people watching have problem requests or anything you're hoping that we cover, don't be shy. Drop us a comment, shoot us an email, mathvideosforparents@gmail.com. And we really want to provide videos that are helpful to you. So that we hope this one is, and we hope we get some requests from you.
Have a great day.